So today we're going to solve using substitution. Now we're still trying to figure out where those two lines intersect at, but without having to use graphing, we can also use some algebra skills here. So we are going to go ahead, and when you're using substitution, you kind of want to think through, you want to either get an x equals or a y equals from one of the equations and then substitute it into the other equation. So for instance, in this first equation up here, you got x plus 2y equals 8. I can solve for x here. So I can subtract 2y, and I get x equals 8 minus 2y. So now I can take that and I can substitute it into the other equation that I did not do that for. And I can go 1/2. I'm going to put in 8 minus 2y in for x. So since this says x equals 8 minus 2y, I'm putting it in there for x. Everything else in the equation is going to stay the same. You have 1/2 times 8 minus 2y minus y equals 18. So now I could distribute that 1/2 through. 1/2 times 8 is 4, minus 1/2 of 2 is this y, or 1y, minus y equals 18. I can combine my like terms over here. Minus 1y and a minus 1y gives me a minus 2y. I'm going to bring the 4 on over so I can get the y all by itself. Still solving here for y, and I end up getting y equals -7. So now I have y equals -7, and I always plug it back into the very first one there that I've got an x equals for, because it makes it really easy to solve. And I get 8 minus 2 times -7. Well, I've got a minus here, so this becomes 8 plus 14, and we get 22. So now I'm going to write it as an ordered pair with x and then y. So I get 22, -7. So that ends up being my ordered pair for that system there. So if you were to actually graph those two out, that would also be the ordered pair where they intersect at. So let's go ahead now and try another example here. We have 2x minus 3y here equals 2. So that first equation doesn't have a 1x or a 1y there. So I'm going to work with the second equation there, and I'm just going to get it as a y equals. So I'm going to subtract x, I could have said x equals as well if I wanted to. So now that I have y equals 15 minus x, I'm going to plug that into the other equation. So it says y equals that, and I'm going to put that in there for the y. So rewriting that first equation, I get 2x minus 3 times 15 minus x, is plugging that in for the y, equals 2. Now I can go ahead and distribute the minus 3 through, and I get 2x minus 45. A minus here becomes a plus 3x, equals 2. And I'm going to still keep solving this. I can 2x plus 3x here gives me 5x minus 45 equals 2. I'm going to go ahead and bring the 45 on the other side. And I get 5x equals 47. So then I can just go ahead and divide both sides here by 5, so I get x all by itself. And I get x equals 47 fifths. Or if you want to go ahead, you could divide that out and get your nice decimal for that. And I believe you get 9.4 there. So working through that, I can continue to work through that. So since my x value there is 9.4, I can plug that back into up here. And I get y equals 15 minus 9.4. And if I do the math on that, I get 5.6. So my ordered pair here, it's always xy, so it's 9.4, 5.6. So let's try another example here. This one here says 7y equals 26 plus 11x, and x minus 3y here equals 0. So that second equation is the only one with the 1x there, and there's no 1y in this, so I'm going to work with the second equation here. So I'm going to go ahead and add 3y to both sides of the equation, and I get x equals 3y. So now what do I do with that? I'm going to go ahead and substitute that into the first equation. It says x equals 3y, and I'm going to plug that into the other equation there for the x. So I get 7y equals 26 plus 11 times 3y. I'm going to go ahead and do that multiplication over there. That 11 times 3y there gives me 33y. I can now get this y all by itself. That's 7y. So I'm going to bring the y's over on the same side. And I get a negative 26y equals 26. I can divide by negative 26. And then y ends up equaling negative 1. And again, I can take that y equals negative 1 and plug it back in there for the y. So x equals 3 times negative 1, which ends up giving me negative 3. So to write the ordered pair out, remember it's going to be xy. So my x value there is negative 3. My y value is also negative 1. It's also negative, so it's negative 1. So there it ends up being solved there. And again, if you were to graph these out, that would be the point where the two lines there intersect at. So that is our solution, negative 3, negative 1. So we're going to continue working on the 3-1 worksheet. So there, hopefully that would help you out there with solving using substitution. All right.